Okay, so last night's homework was on the sheet, the backside, scientific notation. And the first part just asks you to write each of the numbers in proper scientific notation and to keep the right number of significant digits. Okay, so if you remember the rules for scientific notation, you move the decimal so that it ends up between, the number in front of the decimal ends up between 1 and 9. So this one would be 1.20652. All of these digits are significant, so we keep all of them. And then times 10 to the, and then how many places did you move the decimal? 1, 2, 3, 4, 5. So times 10 to the 5th, and you're done. Okay, this one, again, this time you're moving the decimal in the opposite direction, but you move it so the number in front of the decimal is between 1 and 9, so it would be 5.26 times 10 to the, and because you're moving it in the opposite direction this time, it has to be a negative. And then how many spots did you move it? 1, 2, 3. So it has to be -3. Okay, this, and again, how many significant digits? Just these last three. These first three, not significant. All right, next one. Move the decimal so the number in front is between 1 and 9, so it's going to be an 8.702. Now, significant digits. This front 0 definitely does not count. This back 0 does. I corrected I corrected all of your sig fig sheets, and some of you were counting the front one, but not the back ones. It's the other way around. A leading 0 does not count in front of a decimal, but a 0 after the decimal does. Okay? And so that 0 stays, and then it goes times 10 to the, how many spots did we move it? Just 1, but in the negative direction, so -1. All right, 500 with a 0. This 500 with the decimal there and a 0, it means the 0 counts, and so it'll be 5.000. All three zeros stay. We moved it 2 spots, and it's a positive. This one, no decimal. It means those zeros do not count. This will just be 4 times 10 to the, how many places did we move that decimal that's not there? 2. And this one, I tried to trick you. I tried to trick you because, look, it looks like it's in scientific notation, but it really isn't, because the number in front of this decimal is not between 1 and 9, unless you count really weird, right? 1, 2, 3, 32? I don't think so. And so we need to move the decimal one more place. And so it'll become 3.28 times 10 to the, and that's a 3, and we moved it over one more spot, so that will be a 4. Okay, and we're done. That section. The second ones wanted you to write them out longhand, meaning write it out with zeros. And so you have to move the decimal 8 places. So 2998, so that's 3. Oh, and I didn't do a very good break. 4, 5, 6, 7, 8. I didn't separate my sets of 3s very well there. I didn't plan ahead. But it'll have 5 zeros and then those 3 numbers. -4, 0.123 zeros, and then 5002. Now I probably should go back and explain, how do you know for sure? We'll count backwards. I'm saying the decimal now is here, and if I move it back 1, 2, 3, 4, 5, 6, 7, 8, and that's what it was. In this case, I'm saying it's been moved to -4. So if I were to move it back to the original, 1, 2, 3, 4, and I moved it in the negative direction. So I know this number that I've written is correct. Okay, this one is -2, so I need to move it 2 places this way. So it'll be 0.06410, right? Double checking, 1, 2, and that's what it was supposed to be in the negative direction. Next one, I want to move it 4 places to the right. So it should just end up being 96425. right? Because then 1, 2, 3, 4 would put it back to that. And the last one, 5 places to the right. So these first two zeros are 2 of the 5. 3 more zeros should make 5. 1, 2, 3, 4, 5. Now the problem with this one is I can't keep the right number of significant digits. There's no way I can write it out longhand and keep the 3 significant digits that this indicates. All the others, we could do it, but this one we can't, which would be the reason why it was probably the reason why it was originally written like that. Okay, so that was all your homework. The one thing, well, there's 2 things you can work on over the weekend, but the one thing I'd like you to try for homework is this sheet that I gave you yesterday. This is what we would have been working on in class today had we been there. Okay, so it's the one called Rearranging Kinematics Equations. We were just about to start it yesterday in class. So it wants you to take this equation, which you should recognize from grade 10. Acceleration is equal to final velocity minus initial velocity over time. And it wants you to rearrange it for each of these variables. So it wants you to rearrange it first for VI. So if you were to take this equation and rearrange it for VI, so I'll write the original equation here, VF minus VI over delta T. And if you want to get the VI alone, then you need to get rid of the delta T and then the VF. And the other day, one of you said something about ped mass or bed mass. So it's kind of like the reverse of that. So what do you want to do? What do you do to get rid of these things to get VI alone? Well, first you got to get rid of the delta T. How do you get rid of it? You multiply both sides by it, right? And so then when you multiply both sides by it, it becomes A delta T is equal to VF minus VI. And then you want the VI alone, so you need to get rid of the VF. Okay, or maybe I might take the VI over to this side and the A delta T over just to get a positive. So I might add the VI here and here, and I might subtract the A delta T from each side. And so if you do that, you're left with VI is equal to VF minus A delta T. The VI is now alone. If you did it the other way and subtracted the VF, you'd still eventually end up with the same thing. You would have negative VF plus A delta T is equal to negative VI, and then just multiply everything by -1 and you'd get that. Okay? Second one, same idea. Go back and start with A equals VF minus VI over delta T. Get the VF alone. So get rid of the delta T, get rid of the VI. And then for the third one for that, it wants the delta T alone. Okay, and so it goes through 4 different equations. Some of them you probably won't recognize, but we'll get to them in physics as we go on here. So this is just learning how to rearrange. Do you know which thing to get rid of first? Don't stress about it, because you're not going to hand it in. We will go through it all on Monday. I just want you to try. Okay, so for homework, try these. The one that even the best of you are going to get messed up on is this third one. And it's the back part where you're rearranging for time on this third one. So don't stress when you get screwed up on that one. Just set it aside. We'll do it Monday. But I would think the rest of them, you should be able to do okay with. If you don't, though, like I said, you're not handing it in. We'll go over it. Don't worry about it. Okay, so for homework, this please. If you're bored and wishing for something else to do, feel free to try the math review sheet. Okay, we'll talk about it on Monday as well. It's the front side is not to be handed in either. The back side will be by the end of next week, but the front side is just going to be homework. So, if you're like, man, I wish I had more to do, feel free to work on this. Okay? But the one I really want done for Monday, rearranging kinematics equations. So try it. Ask in the group if you get stuck on a little thing, but do not stress. It doesn't need to be handed in, and I just want you to give it a shot. All right. Enjoy your day. Enjoy your weekend.